The phaser is an audio effect which takes advantage of the way sound waves interact with each other when they are out of phase. By splitting an audio signal into two signals and changing the relative phasing between them, a variety of interesting sweeping effects can be created. It's a filter which creates distortion of the sound. For the most part used by musicians, we find it when they are recording music, in drums, guitar, and also in human speech, a phaser pedal concert.
Now you are going to hear the difference between the effect off and on. The phaser effect was created in 1968 by Japanese film animator. The phasing effect was first made popular by the musician in the 60s and has remained an important part of their works ever since it was used for the first time by Jimi Hendrix, who has generalized phaser pedals. This technique was more and more sophisticated, and a digital process has been created which enables the phaser effect to be in the computer. Since the 90s, there have always been musicians who use the phaser effect.
When someone plays, for example, the electric guitar, the instrument returns an electric signal which is sent into a speaker to be heard. But sometimes there is a phaser module between both elements in order to create a sound effect. This module can be a phaser pedal or plugging into a computer. The phaser module copies the signal which comes from the instrument, and the signal which has been copied passes into many partial filters that have as consequence to dephase the signal.
Then both are added and the resulting signal is sent into a speaker. So in the end, the phaser produces a kind of sweeping effect due to the wave interference phenomenon with the addition of the signal. The partial filters have the following characteristics. It filters without really filtering the signal. Indeed, it keeps the amplitude of the signal, but it dephases it. This is due to the specific transfer function of a partial filter. Simply, a transfer function is a mathematical relationship which links the input and the output of the signal. Then, with this function, we can determine the gain response curve which allows us to see the transformation of the signal. In our case, the curve will be almost constant because of partial filter, as we mentioned before, keeps the amplitude. However, it will be the phase response curve which will be constant, and it is the objective of this effect. From now, you will be able to use this tool at every concert you do. So that's all for today. Thank you for watching and goodbye.